This is also a system of equations. This one should probably use elimination. Usually you try and use substitution if something is linear or if you can solve for something, but this one is nonlinear. I can't get x or y by itself without taking a square root, and the same for this one. You can try to get rid of the x's or the y's, whichever you feel like. I noticed that the y's already have the same coefficient, so what I'm going to do is I'm going to add or subtract straight down and try to get zeros here. Since they're both positive, the only way to get 0 is to subtract. So 4x squared minus x squared becomes 3x squared. Y squared minus y squared is 0. That's good. 13 minus 10 becomes 3. So from here, it's just solving for x normally. Divide everything by 3. X squared is equal to 1. And remember, whenever you take the square root of something, you always get a positive and negative value. So you get x is equal to 1, and you get x is equal to negative 1. What you need to do from there is you need to take these guys and plug them back into either of the beginning equations. I'm just going to use the first equation because it's easier mental math. So it's x squared plus y squared equals 10. So I'm going to use 1. So x squared plus y squared equals 10. 1 squared is 1 plus y squared is 10. Subtract 1 from both sides, y squared is equal to 9. And every time you take the square root, 2 answers. You get y is equal to 3, and you get y is equal to negative 3. So this one x value gave you 2 y values. So using positive 1 gave me 3, and using positive 1 gave me negative 3. If we plug in negative 1 for x, I get negative 1 squared plus y squared equals 10. Negative 1 squared is 1 plus y squared equals 10. Subtract 1 from both sides. I get 9, and every time you take the square root, 2 answers. So this one also gave me 2 answers. When I used negative 1, I got out 3, and when I used negative 1, I also got out negative 3, for a total of 4 answers.